Yeah, just let's move on. And let's leave this track with Docker. It was more or less for fun. We are somehow, before lunch we'll end up like here. And we're gonna end up like doing this command. That is actually sort of creating our web application with a lot of boilerplate code, whole framework in there. And once we create that, we get the, well, like we did with the console application, but then we get the whole project for ASP.NET app. So 3.-L1, and after lunch we'll walk through this directory structure, see what it contains, and we'll see an example on how to add model, service, controller, and apply it into this sort of framework. And yeah, we're going to see how the pages are rendered. We're going to see how we could create a just easy REST API. So, and all this is, well, is a bit more than we did with PHP, but because when we had PHP we focused on CRUD and databases. This is a bit more compared like we did with Node and Express. But what we get here is a more complete framework. So then I told you it's hard to compare all these technologies. We had a plain vanilla PHP. Then we had a part framework for Node.js Express. And then we have a complete framework here for the .NET area. So there are different things. But we'll look into this and we'll sort of turn into a few concepts when we are diving into this framework. And that's why we are going back to the slide. I have a few more concepts on it, I think. Just want us to have this with us before we dive into ASP.NET Code-ish. So a few things more before lunch then. Yeah, I think we talked about this. MVC pattern, and the V, in this case, it will be eraser pages if we talk server side. Okay. Yes, we got that. Nice, well, it's a small feature here that we have the page, that we will see the page. We are used to get the page. But here we also have a class directly connected to the page. So it could be easy, it's an easy way to move code between the HTML part and move it to a more programming oriented way. So that we will see. We will see a bit about services and we'll see how those are injected into the framework. Have you worked with dependency injection? In Java or in the course, or did you do it otherwise?
Not really.
No, not really in school. Okay, but let's then just talk through some basic concepts about dependency injection, because it could be good to have that when we move into the framework. Okay, we'll do this, and we also talk about what is a service and what is a service container. It's like kind of general design patterns. Okay. Before we move on there, just wrap up the ASP.NET session. And so what Microsoft, then again, our company, should we go with this? What Microsoft also will provide us is a sort of a hit, what is it? It's not F5, but hit another button and publish our whole project just to Azure Cloud or something like that. So integrated possibility to publish, run, host our small project on a complete environment somewhere out there in Microsoft Azure Cloud. So that also sort of comes connected to this whole package we get. So yeah, it's a nice package. It's friendly. It's a lot of stuff involved in it and some magic. So I have a few general things just want to mention or talk to before we move on. And I start with briefly comparing these type of frameworks we worked with now. So how could we sort of, if we try to go behind sort of the programming languages and so on, what is the general structure of web application area and how could we sort of divide it? So let's just try to think of, we got ASP.NET Core now with C#. We talked a bit about JavaScript frameworks. We talked about PHP frameworks, but we coded PHP vanilla, so got the vanilla structure. You know a bit about Java frameworks. We could do all this in Java if we like to. We could use Python. We could use more languages out there. So, and they are all these. When we are going into the sort of web framework area, then we sort of need to consider how will we work on the client side. And we can use many techniques when we work on the client side. Most likely we use HTML, CSS and JavaScript. Maybe not actually true. Yeah, JavaScript, we can change that to TypeScript. Feel free. CSS, we can change that to SAS or less. And that's so languages that enhances CSS, easier to work with, more language constructs. That is usually the way we might be doing it. Okay, client side. We need to have something with, most likely, a technique to do fetch, Ajax requests. Because some of our pages will do these Ajax fetchish requests, so we need to choose a technique for that. If we are going to do this real-time applications, we need to choose a technique for that. And there are sort of several techniques we could choose from. Okay. But we are still on the client side. If we want to do a bit client-side application, we also need to have a router on the client side. We need to route clicks locally in the browser without actually going to the web server. So just stay on the browser and click, and the request is sort of processed locally, perhaps going to a REST API, getting some JSON data, rendering it locally to get this SPA application. So we need if we want to do that, yeah, we will need sort of a client router. And then what should we do? Yeah, I want to go with React. Oh, Michael, he said something about Mithril last time. He liked that. Or we could do it ourselves. So a lot of technique, but still client-side techniques. We also need a way to render these pages and responses on client-side. We did it ourselves with just JavaScript, creating a new table in section 03, fetch. It's just working with a string and rewriting inner HTML. Doom updated itself. So that was a very rough way. In general, if we were going here with a sort of client-side framework, again then Mithril, React or another one, that will be taken care of and it will be done in a sort of more effective manner. But still, we have client-side. We also somehow need to keep the client-side state when we are working with client-side applications. And there will be a lot of tools that we can choose from. We can do it ourselves. We can use a framework. Again, React could do it for us. Redux, perhaps, another framework could do it for us. Mithril, yes, small framework could do it for us. But it's a lot of sort of features that we might need to be able to develop specific types of applications. Somehow it's easier to think, okay, these are the features I need because in this particular application context, I can really do it with a lot of coding languages or frameworks, but I need a feature. When we are still, let's just stick on the client side. We have perhaps we don't talk about MVC pattern when we are client side. We usually talk about a bit more view model. So it's a bit different sort of design pattern when we develop these client side applications. We might talk about web components or graphical libraries that will help us build graphical user interfaces on the browser by building small components, GUI components, and we're using them. So there is some concept of web components that we can use for that. So a lot of features on the client side. Yeah, just see what would be the opposite on the server side. Yeah, we need some kind of framework that will do a lot of things for us, so we can attach to it. If we were going this PHP, yeah, we should get the framework. Get Symfony or Laravel. For Node.js, yeah, sure, go with Express or something else. Here, ASP.NET, yeah, we get the whole framework already there. There will also be some kind of, on the server side, some service container. So, and we'll see how the service container interacts with the framework after lunch when we look at the ASP.NET framework, because they have this concept of server. We know what the router is because we've done that in Express. We know MVC briefly. We know the template languages. We know the static pages, the REST API. We know what WebSocket on the server. We need to have authentication. We briefly talked about ORM modules to make it easier perhaps to connect to a database in an object-oriented way. So if we are selecting a sort of server-side framework, maybe we want to have that module also. Something we didn't talk about, but I think if, again, our company, this HTML forms automation, we did a bit of CRUD in PHP. But usually when we create applications, there will be a lot of HTML forms sort of to interact with the user, and some of these frameworks will give us some automate our work using HTML forms. So when we are selecting a framework, let's have one small eye open. Is there a way to make this sort of automatic, so we don't need to write the code for HTML forms, processing them, sending them? Couldn't there be some magic around that? And yes, there is, depending on the framework we choose then. Okay, so we have client-side features, we have server-side features. And we have some general helpers that will also come with these frameworks. And we will usually have, let's just wrap them through. We'll have a command line interface. Usually we have a command line interface that helps us work with this. Have you heard concept of scaffolding? No, no, it's not. It's basically create a bunch of so I want a controller. It's basically what I would do in Visual Studio Express 2019. So I want to create a controller. I get sort of a right click. I can select a class with some content in it. So it's generated for me. So the class is scaffolded with some rough data, and I go in there and I can change it.
Flutter is built on it.
Yeah?
Yeah, the whole of Flutter.
Yeah. So we get this when we have, if we would having a more sort of rough framework, plain vanilla framework. Let's take a PHP framework for that case. Let's take Symfony or something. Then we will have a command line interface, and I could sort of scaffold a whole application with it. I could scaffold a CRUD application, could generate HTML forms, could generate the sample controller, sample model. So I get a lot of, what is it, batch code or template code to work with. So that concept is called scaffolding. So that is usually what I get when I select a framework. Yeah. Let's just reusable models, yes. Version management, we talked a bit about. Unit testing, automated testing. Have you done that? Unit testing? Yeah? Okay, good. And I think I mentioned automated testing. Each time we push up something on GitHub, we connect some test system that's actually listening on our commits. They are checking out our programs, they are running our unit tests, and eventually we sort of create a, well, when we do a commit, our code is automatically tested. When it's passing the test, it sort of goes further down this pipelines of test, and it's eventually sort of published up on the actual production server and run. So creating this kind of well, developer operations pipeline. This is also what we would be aiming for when we are doing our selections. But it's tools around us that we need to work with. Microsoft is providing this. So one click and it's all up on the sort of Azure cloud. So something like that. But we would have this if we would go with PHP frameworks. Maybe we add it ourselves. If we would go with JavaScript frameworks, yes, we will add this type of feature ourselves. So that is what we will need. Docker is also sort of a common feature on all these independently on what type of framework we would actually sort of use at the end. That would also be a feature that we would have. So just general frameworks, server side, client side, and try just in your mind divide these sort of features. This is a server side feature. This is a client side feature. This is maybe what I need when I want to do my sort of application. I can really do it in any type of language. And helpers around it. Okay. Let's see if we can do this also. Have you talked about a lot design patterns? So, maybe? No. No.
Software engineering too.
Yeah. No. But you're sort of aware of the sort of concept. It's common solutions to common problems, and they say do a structure like this and everything will turn out right. And it's also giving you, maybe that is the most important thing, it gives you a terminology to talk about your programs. When we have larger programs, like we have here in the framework world, they're giving us some terms. Yes, okay, MVC, yeah. We roughly knows what MVC is. But a service container, dependency injection. I did a factory. So these, it gives us, and you will eventually learn that when you go out there and sort of code among your sort of fellow coders on the company later on. So you will eventually turn up in sort of bit talking about your code using design pattern terminology. So let's just roughly go through a few of those on a high level rather quickly, but still, before we actually sort of go into the ASP.NET code. So if we would, have you heard about Solid? Okay, no? Okay. Now you have. You will, most likely when you go out there and you sort of dive into a new development team and doing these things, there might be someone there. Oh, we must do things in a solid way. We must write our code in a solid way. Like it's sort of a truth in itself. We must be solid. When they say like that, they are referring to 1, 2, 3, 5. It's 5 different design patterns that sort of form this label solid. And it's supposed to give us a higher level view of how we should think of when we organize our code in object-oriented way. And it's connected to something called single responsibility. It's open-closed, list of interface, dependency inversion. So it's 5 different parts. If we should just say very high level, so since it's 5 different design patterns, let's take it real roughly. Your class should have a single responsibility. That means that you shouldn't do a lot of things in one class. So when you are trying to explain to your fellow workers what your class is doing, and you're saying one sentence, then you're saying and then you say another sentence, then you say and. You say a third sentence. Stop around there, these and. So try sort of to refactor the code. So each class has one single responsibility. It's a one-liner to explain what it does. So it's just, you might say it's, so common sense. Yeah, it's common sense, perhaps. But it's a recommendation how you think of when you organize your code. So that would be the S then. The O would be something, let's use this private, public, protected stuff when we use our classes in a good manner. Let's provide so the user of the class can use get an API to my class and can use it. And then I can code inside my class, and I can rearrange my code inside without sort of affecting the usage of my class. But that you can just think of it like it's a common sense of how I use private, public, protected. I use private for the stuff I should do of. The user shouldn't mess with this private stuff. I only do public methods, maybe not properties methods, for those stuff that the user can actually use my class. Okay, so that would be the O. The L is basically, let's compare that to when we are building a program and we are using a lot of classes. So try to make each class being replaceable by a subclass, or so I want, for some reason I want to change how this particular part of my program works. Okay, then I can just subclass it and the whole system will work. You can also solve that if you use a lot of interfaces. So if you use interfaces instead of concrete classes when you sort of tie your program together. And yeah, so you might also say, yes, it's common sense. I always do this. Okay, good. So then you know you are a solid programmer when you go out there and someone else uses this against you. And they are also saying this is an interface thing, and you do interfaces in Java. Yeah. So they're also trying to say you do small interfaces, many specific interfaces. Don't do a large interface that sort of solves everything. No. Okay, yeah, I'll do that. Small stuff, single responsibility. And the last thing would then be somehow depend upon abstractions, not concretions. I would just say, yeah, okay, I use interfaces sort of to connect my classes together, and I depend on what the interfaces does. I do not depend on the actual sort of instance of the actual class. Okay, so general coding rules for how to structure a program so it works and it's easy to modify. Solid. It's a set of 5 sort of, it's a bit older design patterns, but you will most likely hear this sort of, yes, we must do it in a solid way. But it's just some basic coding rules. Are you this is not a design pattern, but it's also a way of thinking of your code. So have you heard the name coupling and cohesion? Yeah? Yeah. So then you might not. So if I would say coupling, let's try to have these classes. This is how we organize our object-oriented code, or code in general. So let's have fewer connections between classes. Could be easier to deal with. So if we have this low cohesion, they are not dependent. A class that is not dependent on sort of 7 other classes. It's only dependent on one class or only on itself. So it has low cohesion, fewer errors to others. Makes it easier to deal with. And if we have high cohesion in a class, then everything in it sort of it's supposed to be there. It's no added feature, nice to have, good to have, useful. It's the things that really relates to it, and only that. So it has a high cohesion. So then we try to sort of build software with low coupling, high cohesion, and that is sort of a nice way to go. You actually don't. When you all start to work with unit testing, then I think that is really since when you're in school, you are not. We don't build too large programs here. We don't. So we don't turn into these problems of maintenance, adding features to code that is old, going back to our code a year later and change it and upgrade it and fix it. So we don't really get into the situations. But when we do unit testing, we often see that this low cohesion, high coupling, it's so much easier to do unit testing when we are sort of abiding these rules, single responsibility also. So unit testing is a sort of good way to actually see that my program is easy to test, it's testable. And when it is, I usually did quite good on this, both solid, cohesion, and coupling. And something about dependency injection also. This is the last couple of 7 slides before we have lunch. So there is a concept of dependency injection, DI. So it's a overall concept of how we can structure our code. And it's not only used in this web framework, it's a general kind of thought. But when we come into web framework, it's in there somehow, and we'll see a touch of it after lunch. How ASP.NET is actually sort of working with that, and is sort of, you should do a service. I don't know what is a service. Well, you should do it because it is sort of a glue that makes your web application framework works, and it's based on sort of dependency injection. These are a few high-level terms. There might be, maybe all of these could be found as individual design patterns. All of these. But let's just say, oh, it's about dependency injection. So we have we are trying to inject dependency. We have an inversion of control. There is a service container or a service locator. Could be lazy loading. This is all about a framework is containing a lot of services. And we need to access these services when we are working in the framework. It's a kind of a global asset. Could be, well, these services could be, well, we had request and response when we worked with Express.js. These are 2 services of a framework. The router is actually a service of a framework. So any type of feature within the framework that might come in handy somewhere when I work in my model class could be a database service. How should I connect to the database? How can I get the database? And this dependency injection or a service container will sort of allow us to code in a solid way. Since we can depend on a service container, we don't need to depend on the actual service. I don't need to do new database in my model class. I'm just get me the database service from the service container. And this database service injected into my model class, I actually don't need to know what type of concrete class it is. I just work on the interface. So this high-level DA concept is well, is mainly a glue for all these web type of frameworks. Let's just see what I have there. Yes. Have a quick look over there. You know PHP? It's a lot of open source and it's a lot of frameworks out there. And they are trying to make these frameworks work together. So they have standardized how we are working with a dependency injection in PHP framework. So it's a replaceable component. And it's really small. In the PHP world and in that particular sort of, I just scroll down to the bottom and just see the code. There is the container interface. So it's a container interface. It only has get and has. So it's a service container holding all these services in the frameworks, and I can get them from the container. It's sort of a global asset. So then I load a lot of services into it, and I know how to get the DA container. And from that, I can get all the other services in the framework. And we'll see a glance on how ASP.NET is doing this. Let's just see my latest slides. Yeah, we can just briefly go through them. Dependency injection, okay. One object supplies the dependency of another object. Okay, we leave it with that. We actually need something, so we need the code to see how it works, to actually sort of get it into our mind. So let's just leave it this. Okay, dependency injection. Yeah, okay, whatever. Yeah, this is also whatever. A dependency is an object that can be used. It's type of a service. The injection is the actual passing of that dependency into a object or a client. Okay, yeah, I really need to have the code behind to actually see how it works. But yeah, okay, I get it. Yeah, I get it on a higher level. So how can things be injected from the framework then? That actually the framework has all these services. So how is it injecting it into my model class? Because I need the JSON file writer service that is available in framework. So we got the constructor injection, we got setter injections, interface injection, different types of how to inject into model classes. Okay, I still need to see how it works. This inversion of control is also then this design pattern, high level. It's basically saying my class does not really create this new database class. So I have sort of inverted the control. It's the framework that's actually doing that, creating the service and then injecting it into me. So it's not, I'm just getting the service. I'm not in control of creating the service. I'm a user of it. Okay, inversion of control. Service container, that is quite easy to grasp. It is a container of all the services that is usable in the framework. So it's a global asset, really. Yeah, okay. Still, I just wanted to go through this so we have it in our back mind, when we are sort of diving into framework stuff. Maybe it makes it easier to sort of actually explain why we are actually creating a service in the next step, and just not another model class, because it behaves a bit different. Okay, so we're going to do that, but we do that after lunch then. We do that, and we open up the code in Atom, and we see how it works. Okay, lunchtime.
I mean, that's much needed.